In question 14, we're asked to show that these four coordinates, A, B, C and D here, are the vertices of a square, that is to say the corners of a square. Now just to try and help visualise what this is really getting at then, might be worth just doing a quick sketch. This isn't the best sketch in the world, but anyway, it's a quick sketch just to try and help visualise it. So when you're told A, B, C, D, that is to say they go in a clockwise motion around the square. So A to B, then to C, then to D, and then consequently back to A to complete the square. So that's the configuration of the A, B, C, D. So if you'll take them in order in a clockwise rotation around the shape. Now, key features of a square, of course, all sides should be the same length, and there should be right angles at each corner. So they're the two key features that we need to be checking, and so hopefully that then gives us a good reminder of what we need to do. So let's check then they're all the same length. So first of all then, what's the length of AB? Well, reminder of the formula there is going to be x, say b minus xa, you might do it as x2 minus x1, all squared, plus yb minus ya, all squared. Okay, so substitute your values in. What we've got here, so xb is 9, xa is 7, yb is 5, and ya is 3. Substitute them in and quickly work it through. 9 minus 7 is 2, so 2 squared, 5 minus 3 is 2, also 2 squared, so that's 2 squared is 4, plus another 4 is root 8. Don't need to worry too much about simplifying at this stage, it's just that the distance AB is equal to root 8. What we now need to show therefore is the distance BC is equal to root 8, CD is equal to root 8, and DA is also equal to root 8. So that's what I will proceed to do, and I'll do this pretty quickly by substituting numbers straight in. So B to C, let's say, so it's 11, so xc minus xb, so 11 minus 9, yc minus yb, so 3 minus 5, 11 minus 9 is 2, so 2 squared, 3 minus 5 is negative 2, but when negative 2 is squared it still just becomes the same as 2 squared, so in each case we get 4, and so 4 plus 4 is 8, and we get root 8 again. Okay, C to D. Okay, xc is so xd maybe is 9, minus xc is 11, yd is 1, minus yc is 3, so 9 minus 11 is negative 2, all squared, 1 minus 3 is negative 2, all squared. Again, it doesn't really matter if it's positive 2 squared or negative 2 squared, it's still going to give 4, so 4 plus 4 is 8, and we're left with the square root of 8. Okay, and finally then, D back to A. So xa is 7, minus xd is 9, ya is 3, minus yd is 1, so we get 2 so minus 2 squared there, plus 2 squared there, equals root 8 again. Okay, so hence we've shown then, I'm going to try and just about get it in the screen, AB equals root 8, BC equals root 8, CD equals root 8, and DA equals root 8. Hence all four sides are the same length. Okay, so let's just put a conclusion here. So all sides same length. Okay, and just let me turn the page. Okay, this time though, now we're going to look at the perpendicular nature of the corners. So what we're looking to do here is let's show you. We're trying to show that A to B is perpendicular to B to C. Okay, just continuing here, just took a little break to re-sketch the diagram, so I had something to refer to on this page. So we're looking to show that then, for example, AB is perpendicular to BC, and that is, so to do this we're going to need to check the gradients and of each line, and then show that neighbouring sides are perpendicular. Quick check then about the gradient formula. The gradient formula is y2 minus y1 over x2 minus x1. So for example, to get the gradient between A and B, we're going to do yb minus ya over xb minus xa. Okay, so that's going to give us, so yb is 5, ya is 3, xb is 9, and xa is 7. So we get 5 minus 3, which is 2, over 9 minus 7, which is also 2, 2 over 2 is 1. So the gradient there of AB is 1. Okay, similarly then, let's get the gradient of B to C. So yc minus yb over xc minus xb. So yc is 3 and yb is 5. xc is 11 and xb is 9. 3 minus 5 is negative 2, 11 minus 9 is 2, negative 2 over 2 is negative 1. Okay. Let's continue to get all four gradients. So then the gradient of C to D is going to be yd minus yc over xd minus xc. yd is 1 and yc is 3, xd is 9 and xc is 11. So we've got negative 2 over negative 2, negative 2 over negative 2 is positive 1. Okay, and finally I'll just squeeze in the gradient of d to a here. So we're going to have ya, which is 3, minus yd, which is 1, over xa, which is 7, minus xd, which is 9. That's going to give us 2 on the top and negative 2 on the bottom. 2 over negative 2 is going to give us negative 1. Okay, so quick summary of that then. We have gradient between A and B is 1, gradient between B and C is negative 1, gradient between C and D is 1, gradient between D and A is negative 1. Okay. Now, if the perpendicular, so if if AB is perpendicular to BC, then the gradient of BC would be negative 1 over the gradient of AB. So that's our key rule that we're going to apply now. So just a quick summary of where we're up to so far. We've got the gradient between A and B is 1, gradient between B and C is minus 1, gradient between C and D is 1, gradient between D and A is minus 1. Now, I'm trying to show, remember, that neighbouring sides are perpendicular, and so if what we have here, the rule we have here is that if A to B is perpendicular to B to C, then the gradient of B to C is minus 1 over the gradient of A to B, so the negative reciprocal of gradient of A to B. Now if you look at this formula here, that can be rearranged to say, well, if two gradients are perpendicular, then actually they multiply to give negative 1. So that's maybe, in this case, going to be an easier rule to try and use to prove the perpendicularity of the neighbouring sides. So let's just check that then. So MAB times MBC, well, MAB is 1 and MBC is negative 1, and some 1 times negative 1 is negative 1. Tick. MBC times by MCD, MBC is negative 1, MCD is 1, so they times together to give negative 1. MCD times by MDA, MCD is 1, MDA is negative 1, and they times together then to give negative 1. And finally MDA times by MAD, MDA is negative 1, MAB is 1, they times together to give a negative 1. So we've proven then that all the neighbouring sides are perpendicular, and therefore all the four corners are 90 degrees. Okay, therefore four corners are right angles. So hence all sides are equal and all four angles are 90 degrees. Therefore ABCD is a square.